Thank you, sir. Now going forward for the technical session, I will request all the dignitaries on the dais to sit on the first row. First row is reserved for all honorable dignitaries. I request all honorable dignitaries on the dais to occupy reserved seats so that Sri B.H. Shrikant sir will start further technical sessions part. I request today's technical session chairman and co-chairman to come on the dais.
After a nice inaugural session, welcome to this two technical sessions. Total 9 presentations will be there in two technical sessions. Pre-lunch session will have 4 papers, and post-lunch session will have 5 papers. Today's both technical sessions chairman is Sri C.G. Mane, our eminent sugar engineer, who has got a vast experience in several private sugar factories. And I also invite co-chairman of this technical sessions, Mr. W.R. Aher, who is also sugar engineer with specialization in boiler part of the sugar industry. Mr. Ayer? Ayer? Okay. Achha. To begin with the first pre-lunch technical session, the first presentation will be made by Mr. Y.H. Gharpure, who is a former managing director of Hindustan Antibiotics Pune, on why this seminar. All this heat and mass balance, which is the basic in all industrial exercises. So far, if you look back to last 75 years, no one organization in this sugar field in the country has taken up this vital subject in the seminar. So that is why we seriously thought of taking up this part, this theme for this seminar, and we got overwhelming response from all factories. I am very happy to see the full audience from all sugar factories. Mr. Aher, please come to the dais. The first presenter will be Mr. Y.H. Gharpure. His brief introduction. Who was earlier managing director of Hindustan Antibiotics Limited, Pune. Gharpure is a science graduate from Bombay University and BSc Tech in Chemical Engineering from Nagpur University in 1956. Mr. Gharpure started his own consultancy as Gharpure Associates in 1985, which has grown into Gharpure Group of Companies, including Gharpure Consulting Engineers Private Limited, Mumbai as well as Pune. Mr. Gharpure has traveled extensively to USA, Brazil, United Kingdom, Europe, Japan, South Korea, Indonesia, etc., 50 countries. He represented India in second UNIDO, United Nations Industrial Development Organization conference held at Budapest in Hungary. He is the fellow of the Institute of Engineers and a life member of Indian Institute of Chemical Engineers. Mr. Gharpure was a member of a Maharashtra Labour Welfare Board. He was associated with a number of committees like High Power Committee for monitoring new engineering colleges and polytechnics, etc. He is currently his founder president of a Technology Transfer Association, Pune. He is founder chairman of Voluntary Executive Forum of India and was founder president of Indo-Japan Business Council. He was earlier in executive committee of MCCIA and IMC, Indian Merchants Chamber, Bombay. He was also member of the CR Divisional Railway Users Committee. He was president of Rotary Club of Pune, Deccan Queen for the year 2015-16. He is also mentor with BIST, BYST Pune for last several years. This is a brief of his illustrative career. I now request Dr. Gharpure, Mr. Gharpure, to start his presentation. Every speaker has been allocated 30 minutes today.
Before we start, let me make it very clear. 30 minutes is not for lecture. Lecture should be as limited as possible. The real time should be given for discussions and question answers.
Dignitaries on the dais, dignitaries of the dais, and friends. This subject of seminar was suggested and accepted, I am told, by DSTA for the first time such a seminar is being held. Now, why this seminar? As Dr. Yadav said, that sugar cane is a wonderful crop. I remember in 1980, I conducted a seminar on similar subject in NCL on alcohol and related industries, sugarcane and related industries, and I called sugarcane crop as a kalpataru. That means I am going beyond what Dr. Yadav has suggested, that it's a wonderful crop because it converts 8% of the solar energy into biomass. And why it is important? Because now we want to make India by 2047 a developed country. Shall I give pen drive?
Presentation already there.
1 minute. Hold on for 1 minute.
विचार करायचं की चालू नाही झालं. Now, as far as the sugar industry is concerned, the Vision 2047, the Niti Aayog has come up with a paper, and it says that by 2047, the sugar production in India will be 6 million tons, out of which 3 million tons will be surplus. What are we going to do with this surplus? We will have to export. And if you have to export the sugar, obviously it has to be very competitive. At the moment, what is happening in sugar industry is that we have a boom and bust cycle. That means sometimes there is excess production and sometimes there is a deficit and we import. When there is excess production, government gives subsidy and exports are made. This cycle is not acceptable if we have to export 3 million tons of sugar. And if this has to happen, then modern engineering practices in general and chemical engineering practices in particular will have to be followed, which means that many old plants and low capacity plants either had to expand or have to be closed. Also optimization and increase in productivity right from sugar cultivation and economic use of water for that, to improving the yields and improving and recovering byproducts will have to take place in a massive way. The productivity principle states that there is always a better way of doing a thing, and that is what we have to look at de novo as compared to what is being practiced in sugar and allied industries today, which includes optimum use of raw materials, increasing material and heat efficiencies, improving quality, and so on. For example, yield of sugarcane crop in India is 69.7, as against in China it is 76, and many other countries have even better performance. So we as a chemical engineer have a wonderful 4 concepts, that is material balance, heat balance, unit operation, unit processes. And we feel that sugar industry should be exposed to these concepts. And what is a chemical engineer? In 1955, when I was studying chemical engineering, I read the book Shreve, and in the Shreve book it says that a chemical engineer is a person who collects data, designs a plant, makes it operational, whether or not data is available or not. That means he has to be a problem solver. And if the sugar industry has to be a problem solver today to meet the challenge of 2047, I think principles of chemical engineering will have to be applied in a big way, and that is why this seminar has been conceived and is taking place. Now, it is not only what I am saying, but chemical engineers have proved their merit. For example, the Chinese president is a chemical engineer, and there are many other eminent personalities. For example, that Intel chief, Andrew Groves, is a chemical engineer. And there are many other walks of life where chemical engineers have done well. Application of chemical engineering in sugar and allied industries can certainly make use of the chemical engineering principles to meet the challenges that we are going to face to achieve a developed India by 2047. Now, why it is important is because we are not only sugar originated in India, but we are occasionally second or first major sugar producers globally. And more importantly, it is a sector which is both agro and industry oriented. So it is a very unique sector. If India has to come up as a developed country, both the agro and industry sector together, which is matched in sugar industry, has to perform well. Now, what is this performance about? This is about this complex operations that places in a sugar factory, sugar and allied factories, and how to optimize its performance and improve efficiencies to application of chemical engineering principles in general and material and heat balance in particular is what we are talking today. Now, as far as the material balance is concerned, by and large it is well known, but there are areas where losses take place. For example, filter fiber, that is the that is the bagasse. There is a certain loss of sugar. Similarly, the press mud, there is a loss of sugar. So the total yield as far as the sugar cane is concerned, the recoveries in terms of sugar or in terms of alcohol are way below the material balance where important ingredients like amino acids, fats, etc., and various elements like silica, potassium, calcium, magnesium, they are not being recovered, they are not being gainfully used, and what is not being done, what is a waste product today could be a very useful product today, provided, as Dr. Yadav said, appropriate technologies are developed and gainful use of materials which are not being recovered from sugar cane takes place. Even take the routine part, that is the recovery. In this table we see India at 10.86, whereas Australia the recovery is 14.08. That means in a very major operation of sugar factory, our performance is way below the global leaders like Brazil, USA, even Colombia has a better performance than average of India. Of course, I must qualify that we in Maharashtra, our yields are almost close to much better than what is projected as an average for India. Now coming to the heat balance, there is certainly scope for increasing the heat balance performance, because one study has indicated that the potential of better use of heat, 20% saving is possible. This is one of the figures that I read in one of the papers, and 20% is not a very small figure. So certainly by saving 20% energy which is wastefully used today, profitability of the sugar industry can certainly improve, and also the global warming issue can also be addressed. So today's subject of heat balance and its optimization and recoveries and reuse is a very important aspect, and that is why we are having this seminar today. Next is if we have to achieve the heat and material balance, and if there has to be a sustained performance, there has to be automation to take place. And I was looking for what are the companies which offer solutions for automating the processes so that consistent performance can be obtained. And here is ABB, which has highlighted that very large saving in energy efficiency and low emission can be achieved through automation. So Indian companies not only have to either modernize and update the capacities of their uneconomic size units, sugar units, but also must do automation so that consistent performance is achieved. Now this is where the chemical engineers takes place. The inner circle is the principles of chemical engineers, that is research and development and design and so on and so forth. And the middle circle is what are the possibilities, and the outer circle is the solutions. So chemical engineering principles in general and mass and heat balance in particular can certainly help the chemical industry to meet the challenge that India has to face of not only being a surplus sugar producer by 2047, but able to export 3 million tons of sugar globally by being economic. Now the picture in between has been edited because it showed the Prime Minister picture, but unfortunately with a Kamal. But what the Prime Minister has proposed is that we want to make sugar belt into an energy belt. Almost what Dr. Yadav had proposed, that sugar cane should become a source of energy, and every part of sugar cane can be gainfully used through the application of principle of mass and heat balance. There was a beautiful picture of Modi ji, but that has been edited out. Thanks to the elections that is going on. Now, if this material and heat balance, which traditionally was being done mainly for the purpose of application and pollution, application for pollution clearance, but then its monitoring during the operations was not being done. Now, newer techniques are coming today, and one of the technique is a digital twin, where you create a virtual factory and compare the current performance with the virtual factory best performance, and from there find out ways that means as to how a sustained performance can be achieved by using this modern tool of digital twin. There will be 2 papers presented in the afternoon on this subject. Now, another part of the important is that the overall sugar content, Kalpataru, as I said, there are great possibilities of preparing paper. In fact, paper is already being made to some extent. Compost can be made, annual feed can be produced, and waxes can be made, fats can be made, and as Dr. Yadav said, that many other possibilities exist. I remember in the annual session I made a presentation that alcohol as a feedstock as against blending and burning. So that also he had highlighted as to how it should be used, and very gainfully. Now, another important technique that is coming over is circular economy. Circular economy means that everything of the sugar cane will be gainfully utilized practically over a period of time. What happens in nature is that nature takes care of its waste, and there is ecosystem which recycles everything, you know. The sugar cane, which is a Kalpataru, as I said, there are areas where gainful use can be made. Technology has to be developed, as Dr. Yadav said, and as a result, the profitability of the sugar and related industries will not only improve, but it will be environment friendly as well. So this is the ultimate goal, and hopefully by 2047 we will have a sugar industry with a circular economy. This is the elaboration of the circular economy, and I am sure that at the end of this seminar you will find light of the day to use the principles of material balance, heat balance with new techniques of digital twin and circular economy to make the Indian industry globally number 1, highly competitive, export oriented, and achieving the goal of 2047 India, developed India. Thank you.
Thank you, Dr. Gharpure. Dr. Gharpure has presented a vision of Indian sugar industry up to 2047, and highlights are very much important for the sake of sugar industry at present. Thank you, sir.
If there are any questions, I will be glad to answer. Thank you. बोला.
You have mentioned about circular economy, the process, technology development, research, which in the most of the cases it is in pilot form. But when it is done in the commercial form, economics assumes a prime importance. As Professor Yadav has mentioned about hydrogen production and its commercialization, the cost of hydrogen production as of today, it stands very tall and high. But how to make it commercialization is also assumes a prime importance. So in which way can you highlight how it can be achieved with economics and commercialization?
You see, if you see my slide, the quotation I gave from Shriv, that is where the answer is there. If that slide can be shown again. A chemical engineer is a person who develops a process, designs a plant, and make it operational economically. And he has those capacity because I have shown that right from the president of China to Intel, chemical engineers have done wonder. Give us the problem, we will give the solution and make it implemented successfully.